We're going to continue to look at solving equations, but ones that are not necessarily fully quadratic. So we're going to start off by looking at absolute value. Now I know solving absolute value is something you've done in another class, but for the most part, you have this problem is 2 times your absolute value minus 1 is equal to 5. Well, if it was 2 times something minus 1 to equal 5, you know you'd want to try to get that box by itself, so you'd want to go ahead and add 1 to both sides, and then you'd want to get rid of the 2 in front and divide both sides by 2. We're going to do the same idea here. We're going to get rid of that minus 1 by adding 1 to both sides. Then we'll get rid of the 2 by dividing both sides by 2. Now that you have it as absolute value equaling, you want to break it apart into two separate equations. If the inside happens to be a positive number, absolute value really wouldn't do anything. So you got to consider the situation if the inside was a 3, because that's what we're trying to get, absolute value wouldn't do anything. But if the inside was a negative 3, meaning the opposite of this, well, then we got to do the opposite of that inside. So if we do the opposite of the inside, we end up getting 3. By the way, we're talking another way to look at it is if the inside's a negative, you do the opposite of a negative and it gives you your positive 3. Then we just solve each one of these. And in this case, we get 1/5. Over here, you could go ahead and distribute and then start solving, or you can multiply both sides by -1 and then solve it. But either way, you get -1. So we get two answers. Typically, you're going to get two answers out of absolute value. One which causes the inside to be positive and one which causes the inside to be negative. Now, as a side note, suppose you had absolute value here equaling a negative number. Well, remember, absolute value is always positive. So will absolute value, which is always positive, ever be equal to a negative? No. So if you would have had the absolute value on one side by itself set equal to a negative, you would know that there is no solution. If you did follow memorized steps, yes, you would get two answers, but those answers would not work in your original problem. Here, we're going to go ahead and solve this. To solve something like this, you'd want to set it equal to 0 and factor it. So I'll subtract stuff over, and then you want to factor it. Remember, your first step in factoring is always your greatest common factor. In this case, it's just an x squared. Then we have 4 terms left. You want to then do your grouping. What can you pull out of the first two? Well, out of the first two, you can pull out a 5x squared. Well, what can you pull out of the last two? And it's a -2. Don't put down just a 2, put -2. Now, you'll notice both sets of the parentheses are the same. That's like your common factor. So you'll still bring down your x squared, pull out your common factor, and that leaves you with that 5x minus 2 for the next part. So you really just have 3 terms, your x squared, or not 3 terms, 3 factors technically, 3x minus 4 and a 5x squared minus 2 all equal to 0. So if you have 3 things multiplied together to give you 0, the only way that can happen is if one of them is 0. So you set the first one equal to 0, which was pretty easy to finish solving. Set the second one equal to 0. Then you could go ahead and add 4, divide by 3, and then you could set the last one equal to 0. So then you'd want to add 2, divide by 5. Then to finish getting x by itself, you'd have to do the square root of a fraction, and remember plus or minus. We didn't have to worry about that over here because plus or minus 0 is still just 0. You want to get that root out of the bottom, so multiply the top and bottom both by √5. So we really get 0, 4/3, and plus or minus √10 over 5. So here we're going to look at solving a radical equation. A radical equation is one that has a root in it with variables under your root. For the most part, you want to get the root on one side by itself. So you want to get rid of this minus x. So add an x to both sides. Now that the root's on one side by itself, we want to undo that root. To undo a square root, we would square both sides. If it was like a cube root, we'd cube both sides. So If you square your square root, it cancels, so we just have this. Over here, we have an x plus 3l squared, but remember, x plus 3l squared is an x plus 3 times an x plus 3, so then you'd have to FOIL out the right-hand side. When you FOIL out that right-hand side, you would get this. Now it's just a nice normal quadratic. So you set it equal to 0 by adding x, subtracting 3 from both sides. This one does factor quite nicely. And then you set each factor equal to 0, and we get negative 6, and we get 1. As a side note, whenever you end up squaring both sides, like we did right here, it's common to get answers that don't work. Those are called extraneous solutions. Now, it's possible they'll both work, it's possible neither will work, and it's likely that one of them will work. So we got to check these back into the original problem. Let's take our negative 6, plug it in right here. So it's 3 minus negative 6, which is 9. 9 minus a negative 6, which would be 9, square root of 9, which is 3. And then we'd have to go ahead and add 6, because you're subtracting a negative, and that is not 3. So it does not work. If we take our negative 1 and plug it in here for both of these x's, we would get the square root of 4, which is 2, and then we'd have to add 1, which does give us 3. So when we plugged in negative 1, it works. So that's our only answer. So here, this is really quadratic. Whenever you have anything that has 3 terms, 2 terms with variables like the first two, and this exponent's double that exponent, it's really quadratic. So you could put it in the quadratic form. What goes in the box is always the smaller of the 2 exponents. What goes in that box is always what you solve it for when you use your quadratic formula. What's in front of your box squared is your a, what's in front of your box the first is your b, and the number that's all by itself is your c. So plug all that into your quadratic formula. Remember to write x or y squared each and every time until you actually finish solving it. So y squared equals, work out the right-hand side, work out what's on the inside of your root, you get 13. Now we got to finish going ahead and solving it for y. So we'd have to take the square root of both sides. And remember, plus or minus. So we have a square root inside of a square root, and there's nothing wrong with that. Some people are bothered by that, but there's nothing wrong with it. You probably have not seen that before, but it's okay. So now we'd want to go ahead and solve this. Take this black square root, apply it to the top, and apply it to the bottom. We get this. You'll notice here we have the square root of 6 in the bottom. You know we don't like having square roots in the bottom, so you multiply the top and bottom by square root of 6 over the square root of 6. So on the top, we have 5 plus something all multiplied by this. You know over here, you could just distribute through. So same idea here, we would distribute through. 5 times the 6 gives us our 30. Up here it was 5 times the x, and we had, or not 5, 6 times the x, and we get 6x. So here it's going to be 6 times our root, so we get this. So when you're multiplying these roots together, you take what's inside of this root times by what's inside of this root. So you distribute the 6 onto here, and the 6 onto your root. And so we get 30, 6 onto your root 13 over 6 on the bottom. This one here is also quadratic because you have 3 terms, 2 with variables, and an exponent of 1/3, which happens to be double your exponent of 1/6. So your box corresponds to what's the smaller of the 2 exponents. Here's your A, your B, your C. We solve it for that box. Plug in your A, B, and C into your quadratic formula. Remember to bring down that y to the 1/6. Simplify your quadratic formula, and we get this. So go y to the 1/6 equals this, 3 plus 1 over 4, which you know is 1. go y to the 1/6 is equal to 3 minus 1 over 4, which is 2 over 4, or 1/2. Now we got to finish getting y by itself. Now remember, a fractional exponent is like taking the sixth root. You got to undo that sixth root, so we'd want to raise both sides to the sixth power. And so here, 1 to the sixth is 1. 1/2 raised to the sixth is 1/64. So here, this is really the fifth root of an x cubed. So you got to think about undoing that. If you got to undo your fifth root, that's raising it to the fifth power. If you got to undo your cubing, you'd have to do the cube root. Or you could think of it as just what we were saying. You got to undo your fifth root, which is raising it to the fifth power, and undo your cubing, taking the cube root. So that's a fractional exponent of 5/3. Another way you can think about it is you have an exponent raised to an exponent. You need to multiply those exponents to get an exponent of 1. So if I raise the left side to a 5/3, you got to raise the right side to a 5/3. So you'd have to do the denominator of your exponent, which would be the cube root. Cube root of negative 27 is a negative 3. Still have to raise it to the fifth power, so you get negative 243. See if you can do this one by yourself and then watch the video. So you'd want to raise both sides to the reciprocal power here, because an exponent raised to an exponent, you'd multiply them and you get this. So then on the right hand side, you'd have to do the cube root of 27, which we know is 3, and then square that answer, so we get 9.